Welcome to Beyond the Press Release, a production of Gorcom, in which we take the time to speak with small cap executives after they put out important news. With us today, happy to have him back, Bernard Tourillon, CEO of HPQ Silicon, trades in Canada, HPQ, and for friends of this, HPQFF. And for those of you who believe in the renewable energy revolution and the paradigm shift towards electric vehicles, then you all know that we're going to need more resources to feed all that, but we're also going to need better processes over the entire supply chain, from creation to disposal, including the production of silicon, which hasn't had a change in process in over 100 years and is still expensive, dirty, and not great for the environment. HPQ is a cutting edge, I said that, a cutting edge Canadian producer of high value added silicon products that are sought after by battery and electric vehicle manufacturers, amongst others. And they're accomplishing this through innovative reactors that essentially permit the one-step transformation of quartz into high purity silicon metal and specialty silicon products. And they're doing that at significantly reduced costs, energy usage, and carbon footprint. And now more than just lip service, because a lot of people are talking the talk. This company's walking the walk, because over the last few years, they've signed at least 7 NDAs that we know of with EV manufacturers, battery makers, and other high-value material companies. And the recurring theme between all those NDAs is HPQ's ability for one-step manufacturing of high-purity silicon, including 3 and 4 and even higher. Yesterday was an update on the pilot plant that already produced silicon in its first test back in December. Bernard, welcome back, my friend.
Thanks, George. I was sort of joking when you said, is walking the walk. I would have some people say mostly crawling, but it's irrelevant. Whatever speed you're going to, we're advancing, and I think this press release shows that we are definitely in the right direction.
Yeah, you're not just talking, that's for sure. So you said in here, this is another milestone reached. Give us, look, there's a lot of elements to this. Give us a layman's synopsis of yesterday's news so we can kind of get the big picture.
Well, we've always said that PureVap is sort of our baby. And the first stage, which was the beginning of the testing, was basically the birthing process, which was sometime long and tedious. Now we have a baby. What the heck is calling me?
That's all right.
Because I knew it'd appear here. There you go. Sorry.
That's
my
okay.
fans are calling me in the middle of they didn't know, like, what? Didn't know they were talking. Anyway, so we had sort of like the birthing event. We have a baby now. Okay. Now what I'm showing are the step for us to become adults. Well, it's very accelerated. So basically, we're presenting the 3-step where we're going to go through crawling. Okay. You got to crawl first before you walk. And then you get up and then you start walking. And then once you figure out how to walk, you start running and you're like moving very, very fast. And in layman terms, okay, the 3-step we talked about here, and it's not very complicated. It's the first step is crawling, walking, running. That's it. And that's
test series 1 is the crawl, test series 2 is the walk, and then test series 3 is the run.
We're running.
All right, so let's go through the crawl part first.
Okay. Go ahead.
Yeah. So, well, I was going to ask you.
I thought you had a question.
It's batch testing being performed and will continue until reaching the key milestone of a successful silicon pour. Mag Beach 2, amongst others, asked the question. So here's the question for you. What constitutes a successful silicon pour to move on to the next step?
Well, that's a funny thing because that's a very visual event. All right. So we go through the entire batch process, okay, and the technical guys will end up knowing that there's a lot of liquid silicon on the bottom of the reactor. Okay. So once it gets to that point, then we will do the pour, and then that batch will come out. All right. So then we will know that every step that we needed to do in the batch process, okay, that batch process might end up having 2 material feeds into it, like the first startup one, and then another feed, and then we have enough material, and then we pour it on. Everything is sort of like been calculated and tested. So far we've done 2 of those tests with the goal of doing a silicone pour. But with normal, immaculate R&D does not exist. You do not reach the first step. You do not reach all the steps on the first test. And this is why we call it crawling. Okay, we have to figure out how to operate the machines, all the tweaks and things. It might be the same thing in general. It's exactly the same thing as a Gen 2, but it's a much bigger machine. So
Yeah,
it takes it takes a few tests to figure out how it works. And at one point, we have silicone that is accumulating in the bottom in the liquid form. We keep it in the liquid form. And then, the guys wear a space suit and, high temperature. We have a picture of that when we did some testing of that material. Okay. But we're talking about more material that's going to be coming out. So we're talking about, as we speak in test 2, it could be up to 20 kilograms of liquid silicone pouring at that time. So
now, staying with this successful silicon pour, when that happens, will we get video of that? Will you guys actually be videoing that?
Oh, we have video. See, even though we didn't do pour, okay, the team practiced going through the process of doing the pour. So because it's a science and an art. It's literally that's what it is. A science and an art to do tapping. So we have a few videos of them tapping, even when we were just doing hot tests. That we're doing the test of tapping, just seeing how it works, how they work close to the system, how we're going to get that to work. So we already have a few internal videos of tapping where there's not enough material at the bottom to show the leakage, but we see inside the reactor. So it's pretty cool.
But I guess you guys are pretty confident you're going to get there.
Oh, we're crawling, the baby has no defect. It's working well. It doesn't need any extra surgery.
Bernard,
so we're very confident that he will eventually, pour.
All right. So walking is test series 2, the reactor under semi-continuous batch production. Now it says here, the key milestone is completing at least 6 continuous production cycles per day, with each cycle yielding 20 kilograms of silicon pour. So I'm going to ask you, some people online were trying to do the math, because the big question is about yield. What is the length of each production cycle? Are you able to tell us that? Because some people think, okay, it's 20 kilograms of silicon per hour times 24 hours or times 6. So can you shed some light on the math?
The math is the capacity of the machine is about 50 tons per year. You guys do the reverse math, how much it is per day. Once we get down to being able to do 6 silicon pour continuously, okay, then we know the system is ready to operate on a continuous, like a nonstop operation principle, 24/7 and those issues. But it already operates 24/7 even when we do tests. It takes us, see, the big cost and with any industrial project is always the startup of the process. So when we do the first tip of batch test, they're the most expensive, the most long-running tests, because you have to bring the equipment to the right operating temperature, and you don't do that by putting the arc to the maximum. There's a science behind this, okay? But once you start doing it on a regular basis and you empty it, you cast the material, and you keep redoing it, and everything gets to be faster. This is why I say we're starting to walk, okay? But we're saying we're crawling because, we got to crawl to get a temperature. There's always going to be the same process at the beginning. That's why I say we crawl to walk, because the startup all the way to the first pour, that's always going to be the same thing. What's going to happen differently is we're going to do more and more pour. Okay, more and more pour during a day, and then we'll get very comfortable how the system operates, and then we'll work forward to the third step when we're going to start to run with the system. It's basically the system is operational, it's ready to work. Now we work on the final adjustment of it. Okay, I think one of the reasons why I wanted this image to be there on the people. Okay, and for me, the running is making sure we continue to have the system operating very, very well, producing silicon, and then we can work on tweaking the purity of the material. All right.
Now let's go back to yield before we talk purity in the run stage. Very simple. I think some people might have missed it, but one-liner: the recovered silicon material will be used as feedstock to produce samples for use as part of HPQ's battery initiatives. All right, samples. For who, how much, can you shed some light? We know there's going to be independent testing, We know there are potential clients and partners. That's exciting to see that that's going to be happening there in the test series number 2. What can you tell us about that?
Okay, well, I'll divide this into 2 things. Okay, regular silicon metal. Okay, that's sold out there. We just need an independent laboratories to tell us the grade of the material is 553 or 202002, which is less than 2000 ppm impurities, and that's sort of become standard material to sell. Okay, so you then have your technology as a standard material to everybody else. When we start going then to battery material and other application material, then we get into the higher purity material, which is for all other industrial competitors, okay, requires additional purification step. So we'll take some material, be tested, see what's the purity of it, okay? But then we will have material that we will take in our battery initiative. Now, I started to allude a bit what we're doing in our battery initiative in our NDA, in our third quarter NDA, in the sense that
MNDA, you're talking about the management, MDA.
Oh, MDA, not NDA.
Yeah, we haven't seen any NDAs unless you want to.
No, you've only, but the MDAs are public, but the NDAs are not public.
Of course.
And we started to allude to this because there was a recurring theme of all the discussion we were having with the battery players and those people, the EV manufacturers and those companies, in the sense that where is the state of the art of silicon for batteries right now, okay? And where is it going to be in the future? Okay. What's becoming very, very clear from the literature, okay, is that the next generation of batteries that are not yet even commercially viable. So those are areas that need little small quantities of grams of material, okay, Those are the future, all right? But what is now being needed is in the micro size, and that will be, the demand will start to be in tons, and it will be moving relatively fast. So we didn't want to be left behind and to developing an over-engineered product at this stage. It's going to be required later, the nano part. So with the guys of Novation, ever since they came on board, we've been really looking at, and that's what I discussed in the management discussion, the information, is that we're really looking at, okay, how can we make the material that the battery manufacturer are using now, okay? Because the growth is going to be exponential. And we're pretty well advanced into this, but I'm waiting for a few internal milestones. Some of them are R&D related to patent filing and those issues, okay, before I will discuss more what we're doing. But fundamentally, the moment we start having our own silicon, we're gonna have some material. We'll send some also to INRS. We'll send some to anybody that wants it. But for our battery initiative, which was very specific, we also are working in that regard.
And by the way, there was something there that said for the Series 2, for the 6 continuous cycles, 20 kilograms per hour.
This doesn't say 20 kilogram per hour. We say 20 kilogram per pour.
Per pour, I'm sorry. My apologies. You're right. I blew on that.
Don't say 20 kilogram per hour. This is what you're gonna make the math. Hey, it's more like that.
My apologies. You're right. I blew that part. So it says this is a key required milestone for the Gen 3 to be considered fully operational under semi-continuous production conditions. Who requires that? Is that an internal requirement that you guys have set for yourself? Is that an industry requirement? Where does that come from?
Because the machine can now work 24/7. If you design a commercial machine, okay, you must design a commercial process that's going to be able to operate 24/7. Those type of industrial process, those type of system, okay, once you start them, because of the cost of starting them, you don't want to stop them. This is why, aluminum smelter, you never want to stop an aluminum smelter. That's why you never want to, okay? So once we get to that point where, hey, we can do it, 24 continuously, blah, 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 so we're going to keep doing it. Now, of course, we might end up stopping because we said, oh, we have a thought, if we started playing with these process parameters, X, Y, Z, we might end up getting better results. That's what we're going to do. And that's what R&D is about. So So this is where, so this is where the stump to the next one is really running it, operating in the closest possible, okay, to a commercial setting to get all the final data point we need. This is okay. This is what's going to be needed. Let's be realistic. There might be some things we might not be able to fully accomplish with the Gen 3, but we will know how to fix it for the Gen 4, or not fix it, but just making sure it works, because there's a question of scale and size.
What do you mean
now,
that? For example, what might you not be able
well, okay, to understand what we're trying to do, what we are doing, that's what makes it so revolutionary, is that we are designing a carbothermic process in an enclosed system, right? All carbothermic processes are done in massive, large, open cast system. We're doing enclosed. Eventually, I'll talk more about this when I talk about other subject, why that's so important. So in a way, what we're doing is we're reproducing at a smaller scale what's being done at a higher temperature. Just as I said, the analogy of the computer, okay? At one point, you needed massive mainframe computers, okay? Then you went down to desktop computer. Now we're going down to our watch having that much technical powers. But every one of those re-engineering, rethinking, went through a few iterations before it was perfect. So
Right,
that makes sense?
Yep. So if all goes as planned, you start, you crawl, you walk, you get to the run point.
Mhm.
Where should shareholders expect the company to be position-wise in about 6 months or so? What position are you going to be in at that point?
Well, I
The
hope
status.
okay. I can't be as open as I would love to for multiple reasons I explained to, but I don't think it's going to be within 6 months, but within whatever amount of time. To be totally honest, once we start walking toward running, we're going to be in a good position, because we'll be making materials, having material, we'll be knowing where we're going. And from that moment on, then we can start to enter into the games of the big boys of saying, okay, we have this new process to make silicone. And what I mean by this is everybody talks about reshoring production. But there's a massive issue with regard to reshoring. There is the fact that there's going to need to be social acceptability of the new technology. So the biggest hurdle that everybody is having in this regard, okay, is how do you reshore using an old technology you booted out? This is where we come in with a much greener process, much more controlled footprint of what we're doing. And what we have as an advantage, because of our scalability, is we can be able to perfectly match ourselves for the other steps that are down the line, in the sense that, and that's probably not going to be us doing it, but what I've learned from talking to industry experts is that surprisingly, in the entire value chain to make solar and electronic silicone, okay, the most difficult and expensive part of doing it is making the silicone metal. We're making the first part of the material. And that's where we're focusing our energy right now. And I am in discussion with people that are looking at implementing complete lines of reshoring all the way to electronic grade purity material. And where we would fit in. Just to give you an example, although
So
the price of
like a partnership or pure customer, you sell your
I'm agnostic, George. At this time, I'm agnostic. Okay, what's going to generate the most value for our technology is what I will end up doing. I'm really going to be agnostic, but the key point is this technology is going to be proven as we start to run. Okay, and there's a 1 million metric ton deficit, okay, of 2N plus material. That's just the mathematics of the environment. Okay.
And the only way to fill that is either new process or
that's either new
$300
plants,
million facilities.
And there's also the issue of social acceptability in regard to the transportation of the raw material and doing those issues. We could be small and malleable enough to place ourselves close to the deposit and to just ship the silicon metal as opposed to shipping the quartz, because you need a lot of raw material. So there's a lot of those issues where we have a lot of advantage. And I'm already, like, I get inquiries from different spectrum of the industry, people that want to want our technologies to become silicon metal operator, people that want to have ideas in their country, says we want to go electronic grade. So we'll be very, very well positioned. And of course, once we started to go from the walk and the cron, it's the difference. We're not talking about doing it, we're doing it. I've said many times, our timing, the timeline we gave to get here might have sucked in the way we've done it, but it's incredibly lucky. It was to our advantage. It just, we could not be in a better position, better place for it going forward.
What can you talk to shareholders about? What can you tell shareholders about? Because you said you're having these discussions. So obviously discussions come from contact. Is it fair to say that, HPQ continues to grow in terms of radar presence within the industry and potential partners and potential customers?
I'm going to be very honest. I've probably tried to. No, I'm always. I hate to say this, but basically, I'm going to be more frank in the way I'm going to talk about it. Well, that might be a better word than
all right.
Honest. I let people judge about my honesty. It's like, I'll be frank. I haven't been pushing it lately because I've been single focused to getting the QRR to birthing, crawling, so that we can start to walk and we can start to run. Because I have no worries that once I reach the step of walking and running, people will come to me. At the same time, okay, because HPQ is developing multiple stool to what we're doing, okay, that hasn't stopped us from continuing to do our other development. It is just that I'm hoping that I'm starting to learn the lessons, which is deliver more, talk less. So in regard to the other project, is what I'm hoping to do, but it's sort of like almost impossible, because when you stop talking, the people that start over talking say, well, he's not talking because he's not working. Just not talking because we're working, actually. So
yeah, I don't think anyone's doubted that. I mean, look, you're always going to have critics. I don't care if you're Elon Musk, you have critics. But
he has more critics now than he had a few years ago. That's for sure.
Yeah, well, yeah, as long as you don't start talking about politics, I guess you'll be okay. But I don't think anyone doubts the amount of work that you guys have put in to get to here. What's your level? Last question, Bernard. What's your level of confidence that we know nothing goes perfect, but you don't need to go perfect. You just need to two steps forward, one step back, try different things. You guys will always solve any issues along the way. But I still have to ask, what's your level of confidence that you're going to be at the walk run stage sometime, next couple in a couple of quarters?
Quarters?
Well, 6 months from now, because figure 2 quarters from now is 6 months. So
okay, people, wake up. Okay. We said it was a 12-month program 6 months ago. Okay. Yeah. We got it to the point where it's squalling. Okay. We're telling you how it's going to become running. When you start to run, it moves much faster. You have to realize. So how can I say the slowest part, the most painful part, unless we get an unexpected, boo-boo with the machine, which I don't foresee, it hasn't happened. Things should evolve faster. So my belief is in the next 6 months of testing that we will be doing, okay, will be much faster than people anticipate. But that's my personal thought.
All right.
So I find it funny, and it's almost the first time ever that I'm almost close on my timeline. And people are now keep pushing it back. This is okay. It makes my life easier. I'm going to be able to beat the timeline. Definitely.
Well, you've trained us, right? So we're thinking, okay, another 6 months from now. But sounds like you think there's going to be an acceleration phase. But your level of confidence, short of the unexpected happening, and that's always possible. We have to discount for that. Level of confidence in you and Pyrogenesis is very high. That you guys are on the right track, and you should be able to achieve these goals.
Yes, but my level of confidence is even higher with regard to all the projects we are entertaining. Okay, we are an R&D development company, And in that concept, there are some part of the R&D which is slow, some part of that's fast. And what I've been trying to do, not very successfully so far, but it looks like it's going to be successful now, is try to find when you are in a long step before you reach the next step, okay? Because it was long gestation before we got to the birthing canal. That's the truth of it. So you got to make sure that you have a lot of, not too many, but just enough exciting project that have the same potential value ongoing, okay? Because if HPQ is just the pure VAP QRR and our battery initiative, then we're just stuck in this area. We're much more than this. We're looking at dealing with a technology that will help reshoring of silicone manufacturing. We're having a technology that's going to allow to meet the 1 million ton shortages, 1 million metric ton shortages of silicone over the years. We're developing technologies that will allow the manufacturing of the silicone materials for batteries for now, this generation and all the next generation. We're working in the fume silica environment into producing a much greener process of doing this as moving forward. We're working with Novation under a lot of very interesting R&D process that's coming into focus. We're actually having now the issues is we have too many good projects on the pipeline. So we have also to manage this. But so everything that we've done, okay, during the gestation of the pure VAP QRR is coming on the fruition. So we haven't really talked about the fume silica, but I will start talking more about this.
I was about to ask that. Yeah, I guess you can start talking about that, because I know you've said in the past that sometimes you're reticent about talking about, Novation fume silica, because you want to make sure investors don't think he's not talking about just the QRR and maybe something's wrong. But yeah, can we get to that point now? You think we're going to start hearing a lot more about the other initiatives?
It's good. The baby is going to start to walk very, very soon. So, then I can, then I can go back to, gestation of the other projects. But that's what it is. And I think also the market environment is going to be much better. Like who would have thunk it, seriously, that a green technology company like we are, okay, would have such a hard time during the last 3 years after the election of one of the most supposedly pro-green government in the US, and they throw $1 billion to it, and that the company that basically did the best result last year was Occidental Petroleum. So I think that market-wise, people are going to, I was reading a report from McKinsey. They're talking, what do we need? Like 3 more trillion a year that needs to be invested now in new technologies, in new processes to make it. Okay.
Well, the great thing is you started that 6 years ago versus everyone just started to try and catch up now. So you're way ahead.
Because everybody's going to be working a lot of things. They're going to be a lab scale. Okay. They're going to be, beginning TRL, and it's not going to be a big company that's going to say, unless there are, there's gun put in their heads because of environmental issues, they're going to make them change it. Even that, they're going to take, as slow as possible doing it. So it's going to require companies that are nimble like us, and we have done it. We have advanced. We advanced it. If you look at this, if you look at the fact coldly, it wasn't perfect, but we got here. And that's already a big track record,
You brought up the example earlier of supercomputers down to the wristwatch, and it required new, innovative, small, tiny companies to make the desktop and all that possible. Microsoft, a 2-man shop out of a garage.
Well, that was Apple.
Microsoft, they're all out of,
Microsoft was a university guy.
Apple came afterwards, but the point is, so it's not out of the realm to think that's going to take, Bernard and Peter to transform to the next level.
Listen, I'm old enough to remember the first freaking generation of Mac 2 computers and those issues, okay? And everything was long and tedious, and we were so excited about that technology, and now you look at it and says, how can we deal with these issues? Oh, my computer is slow, it's taking so it's going to be evolving, and this is what we are. HPQ since July is now a technology company. So it's a new sort of like baby for us to manage, understand the quirkiness, and go present it marketing wise. I think the opportunities in North America and in Europe are massive. And it requires people to have different vision. And I think within HPQ Novation, we have people that are visionaries in what we're doing. I wouldn't say I am one. I get the opportunity to work with visionary people and try to see how we can push their vision more forward.
Bernard, is Friday just for 4 o'clock. Mark's going to close a bit. So, thanks for coming on to, the last part of your Friday to kind of talk to everybody, because everyone's looking forward to this. And can't wait to have you back again, my friend. But congratulations on another milestone. And more importantly, I love the crawl, walk, run. And if there are any really great graphic designers out there in the HPQ Silicon shareholder world, hopefully we'll start seeing graphics, memes, or whatever about that. But crawl, walk, run sounds great, and it sounds like it's going to happen faster than we expect. So thanks for joining us, my friend.
You're welcome.
Dave at home, you've been watching or been listening by podcast on Spotify, Google, Apple, your favorite podcast platform, to Bernard Tourillon, CEO of HPQ Silicon, trades in Canada, HPQ, for friends in the US, HPQFF. For those new to the story, and there's always more of you, because the renewable energy revolution and the EV battery paradigm shift is happening. It's underway. We know there's a lot going on. There's a lot to talk about in terms of the technology here. Get your ground-based foundational information off the Agoracom profile page for HPQ, and then head over to the company's website, do your deep dive due diligence. Thank you for joining us. Have a great day. Have a great day. Have a great weekend. Talk to you soon. Hey guys, this video is over, but don't forget to help your company by liking it and even leaving a comment below. And then don't forget to help yourself by subscribing to our channel and never missing another great Agoracom small cap video.